Continuation of combination permutation problems. This week we are going to focus on how the outcomes is going to differ based on the elements that we choose or that which is going to be repeated or not. Okay? So we already know that permutation where the order matters when we choose the elements, and combination is where the elements chosen or where the order doesn't matter. Okay. We have many equations like this: n power r, n factorial by n minus r factorial, n plus r minus 1 factorial by r factorial, n minus 1 the factorial, and p by r factorial. So where n is the elements available and r is the element that we are going to select. Okay, so the outcomes can be calculated using these formulas. The main thing is when the elements, okay, that we choose are going to be repetitive in the situation, then we are going to use these two formulas. Okay, when it is non-repetitive, we are going to use these formulas. So what are the situations where the elements repetitiveness is a matter in finding the outcomes? Okay, we are going to see with some examples. The first one, how many two-digit numbers can be formed by using digits from 3, 4 and 5? Reuse of digits is allowed. So clearly it shows that order matters in this sum, and the elements reuse of digits is allowed. So it is going to be repeated. The digits are going to be repeated. And what is n? N we know it is 3. It is 3, 4, 5 and a 3 combination. And what we are going to pick is 2-digit number, right? Okay. So there is a permutation problem. So we have to find two events. So first event we have 3 choice. Second event they have another 3 choice because the elements are repeated. Okay, it is going to be 3 choice. The answer is 9. Or the formula you can substitute is n power r. So 3 power 2, which is equal to 9. Okay. So next sum, how many two-digit numbers can be formed by using digits from 3 and 4, 5? Reuse of digits is not allowed. So order matters here, but reuse of digits is not non-repetitive. Okay. So here also the number of choices is 3 and we are going to pick 2 digits. Okay. But since the reuse is not allowed, for the first time the choice is 2 and for the next time the choice is going to become 2. Okay, so it is equal to 6. So see, the number of choices, the number of outcomes is going to be 6 when it is non-repetitive. It is going to be 9 when it is repetitive. So identification of not only whether the order matters or not, and also whether the element is repeatable or not, makes the difference in the number of outcomes. Okay, next let us see. 3 cards are selected randomly and given to 3 players. How many possibilities exist? Give the correct expression that gives the answer. Okay. Does the order matter? Yes, the reshuffling of cards is going to happen, so order matters. Does the element repeat? First time we select the cards and then give it to the first player, second player, and third player. When we are selecting for the first player, there is some option. So we are giving one card to them, right? And then when we go to the next player, the number of available option will be surely reduced. right? So here the now elements are not repeated, and number of cards will be 52, and or that we are going to pick is 3. So that is going to be 3 cards selected. First we'll have 52 options, then we'll have 51 options, then we'll have 50 options, right? So the answer is going to be somewhere around 132600. Okay. So next, a card is selected from a standard deck of cards, then put back and the deck is shuffled. This is done 3 times. How many 3 card hands can we see? So it clearly says it's a card problem, so order is matter. And elements we are going to put back every time we take out the cards, right? So it is repetitive, and the number of cards is going to be same 52, and you're going to pick 3 cards, right? So now the choice is going to be 52 the first time, second time also 52, third time also 52. Okay, so whenever the choice is going to be repetitive, we can see the increase in the number of possible outcomes. Okay, so we have to be very careful with the words, understanding that whether the elements are repeated or not. Okay, we'll see some more examples. Lollipop form has cats, dogs, goats, ducks, and horses. How many ways can you select 3 pets to take home? Okay, we just compare the next problem also. The same thing. Lollipop's form has cats, dogs, cats, goats, ducks, and horses. How many ways can you select 3 different pets to take home? Okay, so in both cases, they are going to pick some pets. Okay, so the order doesn't matter. Okay, how about the elements? This case, they can select any 3 pets. So cat, dog, goat, or dog, goat, duck, or dog, dog, goat, or goat, duck, duck, any combination, or horse, 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 right? So the repetition is possible. Whereas here, different pets has to be taken. So either cat, dog, goat, or goat, duck, horse, or horse, duck, goat. But it cannot be a repetition of 2 cats or 3 goats like that. So non-repetitive. So in both the cases, 5 is the number of choice they have to pick, and they are going to choose only 3 pets, right? So in case of repetitiveness, they'll have this choice of um, the animals. That's going to be 5, 4, 3. It's a combination problem, right? So we have to do it in the combination way. So for this there is a formula, right? We have to use the formula, that is n plus r minus 1 the whole factorial by r factorial and n minus 1 the whole factorial. How we are getting into this formula, that's a separate video. How we are using different formulas, we have got that formula. So now we just substitute the values, and the we can substitute the value of r, n and r, and we are going to get the value as 35 outcomes. Okay, when it is going to be non-repetitive, here it is going to be um, the same formula applied. This is the non-multiplicity type, so here we have to use the other formula that is normally we have used, that is permutation by or factorial. Okay, when you substitute this value, then we will be getting the answer as 20. Okay, now we move on to the next problem. You walk into a candy store and have enough money for 6 pieces of candy. The store has chocolate gummies and horrible Chinese candy. How many different selections can you make? So they are having 3 types of uh, chocolates or candies. You can see some sweets, okay, and then we have to choose 6 pieces out of it. And in which order you take, it doesn't matter. And the elements are repetitive, of course. the elements are repetitive. In this case, I can find that element as repetitive in one way, that is, number of choices is 3,